Welcome to Brain Vision.
Chapter 3, Problem 60 says, list the number of valence electrons in each element and classify them as alkali metals, alkali earth metals, halogens, or noble gases. So first, let's review the trend for identify valence electrons based on our periodic table. This is my rough sketch of the periodic table. When we're thinking about valence electrons, we're going to ignore the transition metals or the D block and only look at the main group elements. If it's in group 1A, 1 electron. Group 2A has 2 valence electrons. 3A has 3, 4A has 4, and that trend continues. There are 8A main group columns, or column 1, 2, 13 through 18 as your main group columns. But as the trend, as you go across, there's 1 additional valence electron. So let's look at the elements that we are given. First thing that we're given is fluorine. Let's refer to where it is on our periodic table. If we look at the periodic table, we find fluorine over here in group 7A. Therefore, it has 7 valence electrons. This group, 7A, is called halogens. So this would also be known as a halogen. Let's move on to B. B, we have Sr, strontium. Let's find that on the periodic table. It is located right here with number 38. That is in group 2A or group 2. Therefore, it has 2 valence electrons. Group 2 is also known as the alkali earth metals. So I'm going to write alkali earth metals as AEM for short. The next thing we have is K, which is potassium. We find that on our periodic table. We'll notice that potassium is located in group 1, so it has 1 valence electron. This group is also known as the alkali metals. So we're going to write that as AM for short. D, we're given neon. Neon is located in group 8A, so it has 8 valence electrons. This group is called the noble gases. And we'll write NG for short. And lastly, we're looking at AT. If we find that on our periodic table, we will find it in group 7A or group 17. This means it has 7 valence electrons, and this group is also known as the halogens. So you can use the periodic table to determine the exact number of valence electrons each element will have, as long as it's in the main group.